Imagine discovering that everything around you is made of tiny, invisible particles called atoms. Today, we'll explore the incredible journey scientists took over thousands of years to uncover the secrets of the atom. Let's go over today's objectives. Understand key historical milestones in atomic theory. Identify major scientists and their contributions to our modern understanding of the atom. Describe how atomic models evolved over time. Recognize how evidence and experiments shaped modern understanding. Let's begin by introducing Democritus. Democritus is often regarded as one of the earliest philosophers to develop the concept of atomism. Lived between 462 to 370 before Common Era. Democritus, an ancient Greek philosopher, was the first to propose the idea that everything is made of tiny, indestructible particles called atomos, meaning uncuttable. He believed the properties of materials depended on the types of atoms they contained. His ideas, however, were based on thought experiments rather than scientific evidence. But not everyone agreed. Standing firmly against Democritus's ideas was one of history's most influential thinkers, Aristotle. Aristotle believed everything was made of four elements: fire, water, earth, and air. Now, here is a question for you. Why was Democritus's idea not accepted as scientific? Democritus's idea was not accepted as scientific because it was based on philosophy, not experiments or evidence. Now let's fast forward to the 19th century. John Dalton, the father of modern atomic theory. John Dalton developed the first scientific atomic theory supported by experiments. He showed that atoms are tiny, indivisible particles, and atoms of the same element are identical in size and mass. Dalton didn't just talk about atoms, he proved they made sense scientifically. Dalton's key ideas were: matter is made of atoms. Atoms combine in fixed ratios in chemical reactions. Now, here is a question for you. What was Dalton's main improvement compared to Democritus? The answer to this question is: Dalton's theory was supported by experiments, making it scientific. But Dalton's model had a problem. If atoms were truly solid, indivisible spheres, as Dalton believed, then how could electricity pass through them? Scientists were puzzled, until one man stepped into the laboratory and changed everything. Introducing Joseph John Thomson, the man who discovered the electron and plum pudding model in 1897. Thomson discovered the electron using the cathode ray experiment, proving atoms are not indivisible. He proposed the plum pudding model, envisioning the atom as a positively charged sphere with negatively charged electrons embedded like plums in a pudding. Now, here is a question for you. What did Thomson's discovery prove wrong about Dalton's theory? The answer is, Dalton thought atoms were indivisible, but Thomson showed atoms contain smaller particles. Thomson's plum pudding model was clever, but science doesn't stop at clever. Other scientists wanted to test it, and one of them was ready to shake the entire atomic world. Ernest Rutherford, the scientist who wasn't afraid to prove everyone wrong. He discovered the atom has a nucleus. Rutherford challenged Thomson's model by discovering the nucleus. His gold foil experiment showed that atoms have a tiny, dense, positively charged nucleus with electrons orbiting around it, like planets around the sun. He also revealed that most of the atom is empty space. Now, here is a question for you. What surprising result came from Rutherford's gold foil experiment? The answer to this question is, most alpha particles passed straight through, showing atoms are mostly empty space. Rutherford's nuclear model was a huge leap forward. The atom now had a nucleus and orbiting electrons. But there was a problem. If electrons were really spinning around the nucleus like planets, why didn't they lose energy and spiral into the center? According to physics at the time, they should have collapsed, and atoms should not even exist. Science needed a new idea. In 1913, Niels Bohr improved on Rutherford's model by proposing that electrons orbit the nucleus in specific energy levels. This explained atomic stability and light emission, and links directly to how we understand electron shells in modern chemistry. Now, here is a question for you. Why was Bohr's model important for chemistry? The answer to this question is, it explained electron shells, which determine how atoms react and bond. Erwin Schrödinger came up with the quantum mechanical model in 1926. He took the atomic theory further by introducing the idea that electrons behave like waves. He developed the Schrödinger equation, which showed that electrons do not move in fixed paths, but exist in regions called orbitals. This model explains the complex shapes of electron clouds and underpins modern quantum chemistry. Now, here is a question for you. How is Schrödinger's model different from Bohr's? The answer to this question is, Bohr said that the electrons move in fixed paths. Schrödinger showed they exist in orbitals. Schrödinger's quantum model changed our view of electrons forever. No more neat circular orbits, but wave-like clouds where electrons could probably be found. Werner Heisenberg, The Uncertainty Principle, 1927. Heisenberg added another layer to quantum theory. His uncertainty principle states that we cannot know both the exact position and momentum of an electron at the same time. Instead, we describe electrons in terms of probabilities. This complements Schrödinger's model and marks the shift to modern quantum mechanics. Here are the key takeaways from today's lesson. Atomic theory evolved from philosophy to evidence-based science. Each scientist built on previous work, correcting misconceptions. Evidence and experiments were crucial in shaping modern atomic theory. Modern atoms are complex, with a nucleus and electron cloud defined by probability. The story of the atom teaches us how science evolves with new evidence and ideas. Stay curious as we continue to uncover the mysteries of the universe, one atom at a time.
Hello, learners! Feel free to drop by and visit our website for more free resources, worksheets, and tuitions. Visit us at www.ansellhillacademy.co.uk today to get started, and subscribe for more updates, tips, and learning materials.